Graphs. Hey everyone! Today we're diving into one of the most powerful data structures in computer science, graphs. Whether you're navigating a GPS, using social media, or even analyzing networks, graphs are everywhere. Let's break it down. What is a graph? A graph is a collection of nodes, vertices. These represent entities such as cities in a map or users in a social network. Edges. These are connections between nodes, showing relationships or paths. Simple, right? But graphs come in different flavors. Let's explore. Types of graphs. First, we have the directed graph, digraph, where edges have direction, like a one-way street. Then, there's the undirected graph, where edges are bidirectional, like a social network's friends. Next, we have weighted graphs, where edges have weights or costs, useful for pathfinding, where measurements of each edge is crucial. On the other hand, unweighted graphs just focus on connections, not distances. A connected graph has at least one path between every pair of nodes, while a disconnected graph has isolated components. Simple but important. Implementing an adjacency matrix in Python. Before implementing, let's learn what adjacency matrix is. An adjacency matrix is a way to represent a graph using a two-dimensional array, where rows and columns represent nodes, and the values indicate the presence and weight of an edge. If there is no edge, the value remains 0. Now let's implement an adjacency matrix, a way to represent graphs using a two-dimensional array. Let's jump into Python. Function that initialize the graph with a given size and create a 2D adjacency matrix. Function that add an edge between node U and VA with an optional weight. Function that display the adjacency matrix in a readable format. Example, usage. Create a graph with 4 nodes. Add an edge between node 0 and 1. Add an edge between node 1 and 2 with weight 5. Print the adjacency matrix. Let's explain this Python code briefly. First, we create a class graph and create functions that initializes a graph in the number of its nodes, size. Then we have a function add edge that connects 2 nodes with optional weight, and the display function that outputs the graph through adjacency matrix. Real-world applications of graphs. Graphs are not just for theory. Here are some ways they impact real life. Navigation systems, Google Maps, Uber. Graphs help find the shortest and fastest routes. Graphs are everywhere and you use it every time. So next time that you use your Google Maps, you will have an idea how it works. That's all for today. Like, subscribe, and stay tuned for more DSA concepts simplified. Until next time, Spear Coders, keep coding.